So welcome everyone. Tonight we're going to talk about networks. I used to say that networks is fun, so I hope that you get the same idea with me at the end of this presentation. Also, I'd like to say that this presentation, the material is suitable to everyone. So whether you have got previous experience with networking, or maybe you plan in sitting for your certification exam, or maybe you have just started your journey in IT, or you may be working in a help desk in IT. So everyone is going to understand what we're going to talk about tonight, and just don't worry, because I'm going to give you a list of resources at the end. So you're going to have some exercises, if you wish, in your own time. Let's go to the first slide and start with a presentation. So what I'm going to do, I'm going to just switch my camera off, because I would like to make sure that my connection stays stable for the entire presentation. And let's concentrate to the slides. I'm going to start with a question. And if you would like to pop your answers in the chat. Can you recognize the valid IP address? So let's start with this first one. What would you say? Does this look like a valid IP address to you? What would you say? Nice, I see. Yeah. Oh, I see a lot of people. Yes, yes, that's right. Yeah. What about this one? Yeah, I'm happy that I see you don't like this one. You don't like it. Yeah, I don't like it either. So that's not a valid IP address. Okay. This was easy. What about this one? Some of you are thinking about it. Okay, so yeah, most of you have answered yes. So this is a valid IP address. This one. Yeah, that's correct. It is a valid IP address. What about, let's do a last one, this one. Yeah, I'm happy to see that most of you have got it correctly. So this again is a valid IP address. This is not a valid IP address, and this is valid. We will apparently explain the reason later. So let's go and see some IP address basics. IP address. IP comes from Internet protocol. Okay, Internet protocol address. Internet protocol is part of the TCP/IP suite. Okay, very important in networking. The IP address, it consists of 4 octets, so it's got the form of something dot something dot something dot something. These are the 4 octets. Okay, that's why I say here it's in the form of x dot x dot x dot x. So what is an octet? Each octet is equal to 1 byte. It's 1 byte long. So we've got 1 byte here, 1 byte here, another byte here, 1 byte here, 1 byte here, and a last byte here. And if you remember, how long is 1 byte? How many bits is 1 byte? So 1 byte equals to, yes, yeah, 8 bits. So we've got 8 bits here. I'm not going to write the whole word. 8 bits here, 8 bits here, 8 bits here, and another 8 bits here. All together makes 32 bits. And this is the length, this is the size of an IP address. But let's answer the last question. Why do devices need an IP address? The answer is, if communications need to happen in the same network, in the same subnet, actually devices do not need an IP address. They can perfectly communicate with each other with their MAC addresses. So in a switching environment, as we say in networks, in a switching environment, so no networks are involved. The whole network is a flat network, the same network. Okay, the communications can be done using only MAC addresses. But when devices need to communicate with other devices in different networks, then they need, apart from their MAC address, they need an IP address. Because we've got this device we call a router, which allows communications to happen between different networks. So my home network is a different network than the internet, let's say. So my home network, my device is my personal laptop or my mobile phone, my smartphone, need an IP address because these belong to my home network to communicate with the internet, which is a different network. Hopefully all this makes sense to you, but let's move to the next slide. Let's analyze here what are the different ranges of IP addresses. I saw the chat, somebody said about private ranges. So the IPv4, sorry, before I continue, let's make sure that tonight is going to be all about IPv4. Okay, we're not going to analyze anything about IPv6, which is totally different. So private ranges. Private ranges is 3 classes. Actually, it's not only these 3 classes, it's 5 classes, but we're not going to talk about the other 2 classes because these are for very particular reasons, like experimental reasons or scientific reasons. Okay, we're not going to talk about these very specific ranges. So we have got these main 3 ranges, 3 different classes. Class A is the network, the 10 network, okay, 10.0.0.0 up to 10.255.255.255. If you don't understand, you will understand in the next slide. So we're going to talk more and more about all this. So all this is going to make sense to you in a while. This class A gives us 128 possible networks of more than 16 million devices on each network. So you can understand that we've got a small number of networks, but a very large number of hosts in each of these networks. Class B is the 172 range. So it's 172.16.0.0 up to 172.31.255.255. Did I go on mute? Sorry. This Class B range gives us more than 16,000 possible networks. And each of these networks have got more than 65 1,000 hosts each. And the last class, class C, is what we usually got in our home networks or small office networks. This is the 192.168 range, and it's got more than 2 million possible networks, and each network can hold 256 hosts. So that's why we use this range for our home networks and small office network. Okay. The public ranges are all the rest. So, for example, we saw an IP address in the first slide. We saw an IP address of 1.1.1.1. So you can see that this IP address doesn't belong to any of these ranges. So this is a public range. And let me give you another one. So 8.8.8.8. This is another public IP address. This specific public IP address, the 4 8s, is actually one of Google's DNS servers. Yes, Alex. So network engineers, whenever we need to test connectivity to the internet, we just ping this IP address, and if it replies, we know that we can see the internet. Okay, from whatever source we're pinging from, we can see the internet. Let's move on to the next slide, which I'm not sure if you're going to be happy if you see that we're going to work with binary. And just not to get you scared, yeah, we're not going to do maths tonight, okay? But I'm sure that you all know that computing is very, very related to maths, and specifically to binary and hexadecimal. No hexadecimal tonight, because hexadecimal is IPv6. IPv4 is binary, okay? I'm also sure that you know that computers cannot speak English or any other human language, so they only understand binary, zeros and ones. Okay, binary system is zeros and ones. And what this means? So zero means no presence of electricity. So the circuits of the computers, whenever they see zero electricity, so it's zero. Whenever they get electricity, the circuit translates it to one. That's why we've got binary. No and no presence and presence of electricity on the circuit. But what have this all got to do with networking? You'll see in a bit, but let's analyze, or let's remind ourselves how binary works. And I'm going to tell you a story here. We've got the lockdown market. So what is the lockdown market? I decided to use this example because I believe that we have all got recent examples of people and businesses want to buy cameras and headsets and microphones and other stuff to enable themselves to work from home. So we've got this lockdown market here. And this is Jen, the cashier, and Ben, who run this shop. And they've got their customers here waiting to order. So the first customer arrives and wants 210 boxes, 210 sets of these items they sell here. And Ben shouts out the order to, Jen shouts out the order to Ben, and poor Ben goes back to the storeroom and gets one box here, brings it to the front, and then goes back, brings another box, and then goes back again 210 times, carries a single box here and there. And okay, this first customer, yeah, it's okay. Second customer starts to feel a bit frustrated. Last customer is angry, unhappy, totally unhappy. So these people here, these two colleagues, have decided that this system is not going to work, and it's going to make things difficult for all of them. So they had a meeting and they came up with this new system. So what's the deal with this new system? They have decided to introduce a system of palettes. So what is this system of palettes? They have got a palette of 128 items. Second palette, 64 items. Third palette, 32 items. Another palette of 16, 8, 4, 2, and a single item. So this first customer with an order of 210 items, they have given this person flags. So this person has got an order of 210 items. So the customer puts a flag here, so he needs a palette of 128 items. And we need to subtract this number to see what we're left with. So it's 82. Okay. Apparently, he puts a flag on this second palette because he can have another palette of 64 items. So 82 subtracting 64, we're left with 18. Okay, 18 items more to go. So he won't put a flag here, but he will put a flag here, 16. Okay, again subtracting 16. We're left with 2, so no flags here, no flags here, a flag here, and no flags here. What we've basically done here is the binary system, and let me do this for you. So these numbers are not random numbers. These numbers come from powers of 2. So number 1 is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, okay, 2 to the power of 3, to the power of 4, 2 to the power of 5, and so on until the last bit. And now the decimal number 210 actually in binary is, so we need to put 1 where the flag is and 0 where no flags appear. So we've got 1 here, 0, 1, 0, 0, 1, 0. And this is the decimal number 210 in binary. Okay. Let's not do 120, which is again the same exercise. Let's do 15, which is very, very easy. So 15, no flags here, so 0, no flags here, another 0, no flags here, 0, no flags here, 0. But with 15, we will need a palette of 8 items. So it's going to be 1 here, plus another 4. So 8 plus 4 makes 12. 12 plus 2 makes 14, and plus 1 makes 15. So 15 in binary is 4 1s. Okay, we don't need the zeros, the leading zeros, but because we have got 8 bits in the octet of an IP address, that's why I chose to do this 8-bit system. Okay, so with 8 bits, 15 is 0, 0, 0, 0, 1, 1, 1, 1, okay, in binary. And let's see now what's the relation between the binary system and networking. As we said before, an IP address is 4 octets. Okay, so these are the 4 octets. 8 bits here, 8 bits here, 8 bits here, 8 bits here. So this the potential values between all these 8 bits are from 0 up to what number? So if I put ones in all bits, what number do I get? Do you know? It's 200, yes, 255, okay. It's not 256, as you might be confused with, because the 0 is included. So from 0 to 255 is 256 actually, but the range, okay, the range of the values is from 0 to 255. So you can see the relation, because each, as we said, each octet is 8 bits long. So the 8 bits will give me this range of values. And if we return here to the first slide, now you will all be able to recognize which IP address is valid and which is not, because of the reason we explained earlier, because of the possible values in each octet. So each octet needs to be from 0 up to 255. If we've got any values less than 0, yeah, okay, minus, I wouldn't, negative numbers in an IP address, yeah, I would never have imagined that. But so let's say this IP address is totally invalid, but this IP address is valid. As valid as this one. This is not valid. It may look valid because of this octet and this octet, but these 2 octets, they exceed this range by far. Okay. And let's go back to our slides. Subnetting. So let's do our very first subnetting exercise here. Let's imagine that we have got this headquarter building, and we have got a team of network architects and a team of network engineers. So the team of network architects have decided that this HQ building needs to get a range, an IPv4 range of 10.0.0.0 up to 10.0.7.255. So this entire range needs to be needs to be allocated to all these devices here in these different departments. And the network engineers have decided, okay, let's create subnets. But why? Why do we need to create subnets in this environment? For 2 reasons. Number 1 reason, for security. Because we wouldn't like marketing people to be able to reach HR resources, or we wouldn't like IT people to be able to reach finance resources. Okay, so we apply subnetting for security reasons. And the other reason is, in networking, we've got something we call a broadcast domain. So a broadcast domain is, imagine when you've got a very big network with a lot of devices. Each time you connect a new device in the network, it needs to discover the other devices in the same subnet. So what it does, it broadcasts a packet, so it creates some broadcast traffic. Imagine it's like me being in a crowd and shouting out loud to try and discover my other peers in the crowd. So imagine each of the new devices sends this broadcast traffic, and it's basically noise in the network. Okay, so to eliminate this network, this noise traffic, we just, network engineers decide to subnet, to create smaller subnets in the network, so to keep this broadcast traffic within each subnet, not to allow it to affect the entire range, big range, okay? These are the two reasons we subnet our bigger ranges. So the network engineers, let's go back to the example. The network engineers, they were given this range. So they say, yeah, okay, we've got 1, 2, 3, 4, 5, 6 teams here, 6 departments. So let's do the obvious. So this department, we're going to give it a range of 10.0.0.0. So let's start from here. And let's go up to 10.0.1.0. So what they've done here, they have, oh, sorry. My mistake, apologies. What happened to my eraser? Yeah, sorry. Let's go up to .255, okay. .0.0.255. And this is the first range. Okay, so they decided to do what? To keep the network 10.0.0.0 up to 10.0.0.255. So basically they have given this subnet here this capacity to support 255 devices, okay, in the same network. Next is accounting. So accounting is, since we left the last IP address here, so they have exhausted this last octet because this is the maximum value it can get. So they move on to this other octet. And the starting IP address for the accounting network is going to be 10.0.1.0 up to 10.0.1.255. Okay, again, the same philosophy here. They exhausted the last octet for the one network, okay, and they have decided to give this accounting network, this accounting subnet, another range of a capacity of 255 devices. So I'm going to ask you now, following this philosophy, this logic here, what do you believe the range for this subnet is going to be? So they have left from here, so they have exhausted this range for the one subnet, and they need to start from what IP address? 10 dot. That's correct. That's correct. I'm happy you can follow. Yeah, that's correct. 10.0.2.0 up to 10.0.2. Again, 255. Okay. So again, the same philosophy, the same strategy here, 255 devices on the two subnet, and it's going to be the same. I'm not going to write the whole thing, so it's going to be 3.0 up to 3.255 here. As you can guess, this is going to be 4.0 up to 4.255. And the last subnet, 5.0 up to 5.255. Okay, it's 10.0 for all this at the beginning. And they have ended up with what? Since they have exhausted the range up to 10.0.5.255, what are they left with? They have got the 6.0 up to 255, and the 7.0 up to 255. So, and this is the end of the range for future implementations. So if they want to, let's say, deploy a Wi-Fi network, or deploy a new department network, or smart sensors, or any other implementations, they would only be able to use these two spare ranges, okay, which is, yeah, okay, it's not bad, but it's not ideal, because they only have these two ranges to future-proof their network, which is, yeah, okay, not quite ideal. And this is the easy way of subnetting our big range, but actually this is not what network engineers do. Okay, this is the wrong way. This is the flat way of doing things, which is not correct, because I deliberately omit here to include a factor which is a critical factor for us to decide upon subnetting a network. But before we go to the next exercise of subnetting, let's explain the subnet mask. So what is the subnet mask? The subnet mask is the critical component to identify the scope of a network range. So if you see here, these subnets, okay, these ranges, these scopes are missing something, a piece of information, which is the subnet mask, and this one here. Okay, so the subnet mask is this piece of information to inform us of the subnet's capacity, okay, of the subnet scope. In binary, what does this mean? The subnet mask in binary is a series of consecutive ones to indicate the network part, followed by a series of consecutive zeros to indicate the host part. And I will explain in detail what I mean. And let's work on this first example. So we were given an IP address of 10.0.0.0. What does this mean? Without a subnet mask, nothing. Okay. But they have given us also the subnet mask. So this subnet mask, let's do this in binary, okay? Because now we know how to work on binary. It's a series of consecutive ones for the network part. And this subnet mask, so 255.255.255.0, this is a very, very common subnet mask, usually met everywhere in networks. Okay, I'm very sure that I'm pretty sure that you have met this subnet mask before. So 255, what does this mean in binary? If you remember from the previous slide, it's 8 ones in a row. Okay, 1, 2, 3, 4, 5, 6, 7, 8 ones here, dot, another 8 ones here, 1, 2, 3, 4, 5, 6, 7, 8 ones here, 1, 2, 3, 4, 5, 6, 7, 8 ones here, and how many ones here? 0. So we haven't got any ones here, it's a 0. What does this mean? A series of consecutive ones. This is my series of consecutive ones, followed by a series of consecutive zeros. This is my zeros. So this means that the network part of this IP address is all the ones. So in this octet, first octet, where I've got 10.0.0. Okay, this is my network. This last octet here, the 0 in the end, is another 0 as the previous ones, but the difference is the subnet mask says that the subnet mask gives me a 0 in the last octet. Can you see here? So this, my subnet mask indicates that this last 0 is my host. So the network is a 10.0.0 network. All this is going to stay the same, but the last octet here, the last part, is for the host. So this host octet is going to take values from 0 up to 255, because this is going to change. Okay, this is going to remain the same because it's my network, but this is going to change to give me a unique IP address for each host. I hope this makes sense to you. So this potential IP addresses for this subnet, for this network is 10.0.0.1, 10.0.0.64, let's say. Okay, these two values can be found here in this range. So all these values from 0 up to 255 is my host. Okay, let's work on the same, or on the second example here. Again, I deliberately kept the same IP address, so it's going to be 10.0.0.0, but I have changed the subnet mask. We've got a different subnet mask. I would say that not all of you are familiar with this subnet mask. I'm pretty sure that this looks more common to you, more familiar, but this one, .128, some of you might say, okay, what's this? I've never heard, I've never met this before. But let's see what this means. So let's go back to binary. According to binary, this subnet mask, what's this? 8 ones here, 1, 2, 3, 4, 5, 6, 7, 8 ones here. Okay, another 8 ones here for the second octet, 1, 2, 3, 4, 5, 6, 7, 8. Another 8 ones, 1, 2, 3, 4, 5, 6, 7, 8. But we've got something here. It's not 0 as before. Let's go back to binary. Let's go here. What's 128 in binary? It's 1 here. We would put a flag here, 1 here, and all the rest bits would be zeros. So I've got a leading 1, sorry, and 7 zeros. Let's go back to this slide with the subnet mask. So here, for 128, we've got a leading 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. And my subnet mask here tells me what? The network part of consecutive ones is up to this point. This is my network. And this is my host. The consecutive zeros is my host. So now, what we see, that this same IP address as before will not go up to 255, because my network now is a 10.0.0.0 network, but my host part is not up to 255, is up to what number? What's the maximum number? Because I landed my, yes, I'm happy to see that there are some answers, some correct answers in the chat. Yeah. So because I decided, my subnet mask told me to land my last one here, which is the number 128, this is going to be my maximum capacity for this this combination of IP address and subnet mask. And because in binary we said that 0 is included, so the range is going to go up to 10.0.0.127. This is the range. Okay. we're going to do similar exercises shortly. Okay, if this is the first example, so I don't expect anyone to get it from the first try here. But in binary, if you analyze this, wherever you land, wherever the subnet mask tells me to land my last one, it's going to be the capacity of the range. Okay. And let's go and do now proper subnetting, not as before, like flat networks. Okay, proper subnetting. And let's introduce another term, VLSM, which stands for various length subnet mask. And network engineers do this all day long. Okay, various length subnet mask, because the ways we subnet networks, we have got a factor here which decides the ranges, which is the network capacity. And unlike here, so here we didn't care about capacity of the networks, flat 255 networks all around. Okay, but here we're going to include the capacity of its network. And how do we work on various length subnet mask? We always start from the biggest, from the largest subnet. In this case, it's this one, research. Okay, so let's do our binary here. Let's do the math. 128, 64, 32. Whoever is going to take up networking seriously, you're going to learn this by heart very, very quickly, because you're going to work on them all day. Okay, 16, 8, 4, 2, and 1. 68. Okay, let's see what is the starting point of my range, what is my subnet mask, and my subnet mask will determine, sorry, what will the last IP address of my range be. Okay, we need to give IP addresses to 68 devices. Where am I going to land my last subnet mask 1? Can you guess? On what bit do I need to land my last 1? Yes, Alex, here. Okay, here. So my subnet mask is going to be 255, 255, 255, and what number? 128. Because if I want to give 68 IP addresses to this, if I want to support 68 IP addresses for devices here, if I land my subnet mask last 1 here, can you see? 64. I am short. And binary system, whether I like it or not, I cannot give the exact number, because this is how binary works. So the next biggest number from 64 is 128. So to support 68 devices here, I need to go at least to 128. Okay. So this is going to be my subnet mask. And what is my range? Apparently, I'm going to start from this first number. Okay, so it's going to be for research. Let me do it this way. It's going to be 10, 0, 0, 0, up to what number? This is, so this is my, from this point and left is all ones, okay? To remind you, it's all ones here, ones, 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 and 1 here, this is the last one, and all the other 7 bits are zeros, okay? So this 0 bits, 0, 0, 0, 0, I need to add them all together to take a number of, okay, 127, okay? And this 127 is going to be my last number of this range, okay? So my range for the research subnet is going to be 10.0.0.0 up to 10.0.0.127. Okay, different IP addresses to support capacity for this network. Let's do so. Now that we've done the subnet for research, the various length subnet mask technique is to move on to the second biggest subnet, which is this one, 34. So according to binary, where do I need to land my last one of my subnet mask in order to support 34 devices in this subnet? Where do I need to land? Yes, on the 64, because 32 is less than 34. So 2 devices are going to stay without an IP address, which is not good. So I need to go here. And this is going to be my last subnet mask 1. And all the rest are going to be zeros. So again, same as before, I've got a subnet mask of 255, 255, 255 up to here, okay, and two ones here. So it's going to be dot 1, 1, and 6 zeros, okay. And since my last IP address for this range is 127, I'm going to start where I left from. So my IT range, IT, is going to start from 10.0.0.128 up to what number? Let's go again, subnet mask and binary system. This is going to be my network, okay. From this point and left is my ones. What about my zeros? My zeros, if you add all this together, it's going to be 10, 0, 0, up to, yes. So 128 plus, plus 63, so it's a capacity of 63, okay, so it's going to be plus 63 here, so it's going to be 191, that's correct. Okay, this is my hosts are going to be 63 different IP addresses here, so it's going to start from 128. If we add these 63 different IP addresses, we go up to 191. Okay, and if you do, if you'd like to grab a screenshot from this slide to do the exercise on your own, in your own time, because it's going to be the same, okay? The same for all of them. So next in line is this marketing. So we need to find the capacity to support 25 devices. So we're going to land the last subnet mask 1 is going to be landed here. So it's going to be ones here. And apparently the capacity for this marketing subnet is going to be, if we add all this together, so it's going to start from here 10.0.192. And if you do the math, it's going to end, I believe it's going to be, we said that this is the last one, and this is the last one here, and this is the first 0, so it's going to be 31. Okay, so 192 plus 31 is 223, if I'm not mistaken. Okay, this is the range. And this is how it goes. So in the end, the network engineers and the network architects are very, very, very happy and pleased because of what? What reason? The rest of the range, is spare for future implementations. Okay, so if you see, if they subnet all the large network to support all these departments following this various length subnet mask, they barely touch this third octet. So if they go up to 10.0.1 something here to exhaust, to support all the requirement here, can you see with the previous exercise, subnetting number 1, they only had these 2 spare ranges for future implementations. But now, can you see, they have given IP ranges to support all these teams, and they have stopped somewhere here in the .1 something. So from the .1 something, look at how many spare ranges and how many spare IP addresses they've got. Okay, this is the whole purpose of various length subnet mask, to preserve IP space. Okay, I've got 2 questions here, I believe. If you get to more than 255, so you have to spill into the, yes, yeah. So I deliberately kept my numbers and my subnets in low numbers, so that we can understand what's going on with the octets and the subnetting. But let's say, for example, if this first research network had more than 255 clients to support, so let's say it had 300 computers here, apparently the first range, 10.0.0.0, so the first range, let's say 10.0.0.255, even if I wanted to give them the whole last octet of 255, again, it's not enough, can you see? So I would need to take up something from this octet. Okay, I deliberately kept it simple, but yeah, this is the case. So in order to support more than 55, I need my subnet mask to indicate that the consecutive 1s and the consecutive 0s for the clients are going to be here in this octet, not this last octet. Okay, so my subnet mask would be in form of 255, let's say 255. Let me do a real example. 254.0. This could be my subnet mask, because this octet is going to be. Let me do the binary again. Sorry, 64 is here. 32, 16, 8, 4, 2, and 1. So this octet here, so this is going to be 0 apparently, okay, to support the full capacity, full range. This octet, all these numbers would be the 1s, so this is going to be taken by my subnet mask, and my subnet mask is 254 if you add all this together, and the one is going to be here for the clients. Okay. I'm going to show you my resource. It's a very nice tool which makes the exercise for you. Okay. Another question: are we considering the broadcast address while computing? Yes. Yeah. So in subnetting, we have got something called network IP address and broadcast IP address, which is the first and the last IP address of the range. So apparently this first IP address and this last IP address are not going to be assigned to any computers, any client devices, any endpoints, okay? Because the first IP address is for the network, the last IP address is for broadcast. So whatever range we've got, we need to calculate -2 addresses for our capacity, network capacity, okay? Next question. Is it a trade-off between the capacity to add more subnets and the capacity to add more hosts to any one subnet? Yes, yes, it is. It is. Thanks, Stefan, for your comment. Thank you. Let's go. We haven't got a lot of slides more. So CIDR notation. CIDR notation, don't get scared by the name, because it's a very simple, very simple strategy here. Classless interdomain routing. It is basically a different way to describe my subnet mask. Okay, instead of saying my subnet mask is 255.255.255.0, I say something different, which is very simple and easier than this. I say that my subnet mask for this for my network is /24. And where do I get this? From my ones. This number /something is my ones. I've got how many ones here? 8 ones here, 8 ones here, 8 ones here, 0 ones here. So 3 times 8 /24. If we go back here, this subnet mask, 255.255.255.128. What slash is this? Slash what? What number? 8 ones here, 8 ones here. The chat, 8 ones here, and how many ones here? Yes. So 8, 8, 8, 3 times 8, 24, plus another one here. It's a slash. This one is a /25. Okay. Let me ask you something more advanced. What is the /CIDR notation for this subnet mask here? So 8 ones here, 8 ones here. How many ones here? Yes, yeah. Can you see here? It's 7 ones here. So 7 ones here. Okay, these are ones, it's not numbers. 0. So 8, 8 plus 7, it's a /23 network. Okay, that's right. I'm very pleased that you can follow me. Yeah, this is basically the CIDR notation. Okay, if you ever see something like, what is your IP address? My IP address is 10.10.2.1/24. So what does this mean? This means that I'm sitting on this IP address and I'm on a /24 network, which means what? Which means that my subnet mask is this one and makes my network IP address to be this one, and this is my client IP address. So my network is the 10.10.2.0. Can you see here? This is my host, that's the 10.2.0 is my network, and my device's IP address is the .1 from this range, and the range is a /24 range. So /24 range means from 0 to up to 255. Okay. Default gateway. So what is the default gateway? The default gateway is another component of the network configuration of any client device. And let's give me a moment to explain here. So if you go to your network settings of any device, you're going to have an IPv4 address or IPv6. We have started implementing IPv6, which is a bit scary for simple users to understand. It's a bit scary for network engineers also. So, but let's not explain the scary parts now. IPv4, okay. IPv4 IP address. So let's say 192.168.0.34, for example. Okay. Yeah, Jim. Yeah, that's it. So let's say my smartphone at home, IPv4 address 192.168.0.34. Okay, subnet mask, because this is another component, subnet mask. Let's say the easy one, 255, and 0. Okay, so this is a /24. The most of the interfaces in presenting network configuration do not go by the CIDR, so it's going to be the full subnet mask presented there. Okay, and they've got another component there, default gateway. But what's this? What's the default gateway? Default gateway, what is this? Let's do a little bit of networking. Okay, in networks we use this ellipse to symbolize the router. Okay, and squares for the switch. The router, as I said before, the router is the device, the network device to allow communications between different subnets. Okay, the switch is the device to allow communications within the same subnet. Okay, the switch doesn't do, the switch doesn't know how to route packets from one network to another. Okay, it only knows single networks. It's the router to route packets from network A, let's say, to network B. Okay, so imagine we've got network A here is the 10.0.1.0 network. Network B is 10.0.2.0 /24 both. And let me demonstrate my fine art skills here. So we've got a computer here, a laptop, and it's got an IP address of this range. So let's say it's 10.0.1.33, for example. Okay, and we've got another computer here, another laptop, 10.0.2.33. Let's keep the same last octet. Okay, these two computers will never be able to communicate with each other without a router. Okay, different networks. The switch doesn't know how to route packets to different networks. Okay, and we've got the router for this job. But the router needs something very, very important to be able to route packets from this network to the other and back. And the devices here need their IPv4 address as above. Okay, their subnet mask. What is the subnet mask of a /24? 255.255.255.0. Okay, this is /24 subnet. So we've got the IPv4, we've got the subnet mask. What is the default gateway? The default gateway IP address for the devices here in this subnet and for devices here in this subnet is to put it very, very simply, the router has got interfaces, okay? It's these slots where we plug the network cables. So this switch is plugged on this router interface. And this switch here is plugged on this router interface. And because this is a router, the router needs IP addresses for its interfaces. The router's IP address for this interface is going to be something on this subnet, because it needs to be in the same subnet facing. So this interface needs to get an IP address of this subnet because it needs to be in the same subnet as this entire network segment. Okay, and this network interface of the router needs to be assigned an IP address of this range here. Okay, so imagine that the router has got two legs. One leg is on this subnet, the other leg is on this subnet. And for this reason, it will know, because it knows the two subnets, it knows where they are, and it knows where to send the packets. So packets coming on this interface, packets coming on this interface, which want to go to reach this subnet, the router will take them from this interface and will route them to this interface, okay, and route them here to go and find their destinations. Now the question, since the router needs two IP addresses, one from this subnet and one from this subnet, to be assigned to the two IP addresses, yeah, to be assigned to these interfaces, what are these going to be? Traditionally, it's going to be either the first or the last IP address from any given subnet. Okay, so let's say for this subnet, this interface is going to get an IP address of 10.0.1.1, or maybe some other network engineers would choose the 254 IP address. Okay, I like the first one, so let's do the first one. So this computer here is going to get an IP address, this one, subnet mask, this one, and default gateway, the router's interface on the very same subnet. Okay, so for this computer, the default gateway is going to be this IP address, 10.0.1.1. Can you see? It needs to be on the very first, on the very same subnet. This computer here, IP address, subnet mask /24, so it's the same as here, but default gateway, again, it needs this interface's default gateway, its local interface. So for this interface, let's give it again the first IP address, 10.0.2.1, okay, here. So for this computer, IP address, subnet mask, and default gateway is going to be this one. And that is the default gateway, okay. Resources. Let me put the resources on the chat. So this is I believe that this is a very, very well known command that most of you have used. Sorry. Accidentally, I put the command, I put the chat only to one user. So this is a very, very well-known command. I believe that most of you have used troubleshooting networks, okay? This very, very useful tool, I'm going to show you in a while what it does and what it is. So it's this one. And this last resource is a website explaining all the things we analyzed tonight. So I'm going to demonstrate the first two to you, because the last one, because it's a website and apparently it's got some ads on the website, and I wouldn't like to open it just now. So you can just open it and go and see what's on. Please allow me to stop sharing this screen and go to my other screen. Okay, here. Okay, sorry about that. Okay. I'm not sure. Can you see my screen with the IP calculator? Yeah, okay, cool. So this is this tool I was telling you about. So I like it very much because it explains the binary system as well. So for example, let's do our subnetting, okay? And let's do two examples, one with less than 255 hosts in a network and one with more hosts, just to see the difference in the subnet mask, okay? So let's keep it simple. 10.0.0.0, okay? And let's say that we need a network of /28, for example. Let's see what /28 means. Calculate, and if you see here, can you see /28? I need 28 ones in my net mask, in my subnet mask, which, can you see? Full 8 ones, first octet, another 8 ones, another 8 ones, /28, another 4 ones in the last octet. And this makes a subnet mask of 255.255.240. Okay. And the network apparently is a /28 as here. Minimum host IP address, the .1. Maximum host IP address, the .14. Can you see the capacity of this network is only for 14 devices? Okay, it's a very, very small network. Now you're going to ask, okay, will we ever work with this small network? Yes, you will, because let's say some smart meters, sensors in a network. How many cameras, maybe? Okay, how many cameras will you have in a floor, on a floor? Okay, or a small office. Okay, I believe that it's enough. So in order to preserve IP space in your networks, yes, you're not going to give a 255 capacity network for only to support, let's say, 10 cameras. Okay. Let's do another one. So let's say, what is a /22? Okay, we did /24 and more. Let's do a less than a /24. Let's do a /22. What's this? So can you see? Again, my IP address starts from 10.0.0.0. My subnet mask is 22 ones. So 22 ones, my last one lands on the third binary digit from the end. Okay, so these two zeros are what binary digits? My 1 and my 2. Okay, so this is the subnet mask 255.255.252.0. And what is the range? It starts from the .1, and can you see? .1, .2, .3, .254. So somebody had asked me before, can this 10.0.0.0 IP address be assigned to a computer? Okay, because it's the 10 network. If it was a different network, so the zero, we cannot say for sure because we need the subnet mask. So the 10.0.1.0 or 2.0 or 3.0 are valid IP addresses for devices, for computers, because look at the range. The 2.0, for example, is perfectly good for a computer here, or in this example here, because my network is able to hold how many devices? More than 1,000. Okay, so this is a very big network. Again, now you could say, okay, very big network. Yeah, but imagine a conference room with Wi-Fi devices. Okay, it's very common to see big networks in Wi-Fi implementations. Okay, to support all these incoming clients, customers, users. I've got a question here. In this case, with such a big range, would you require routing to communicate between all devices? No, because it's the same subnet. Okay, it's a very big range, but it's the same subnet. Okay, so you don't need routing. Routing is between different subnets. Okay, routing would occur. Let me bring my slides here. Okay, routing would occur between, let's say, marketing and accounting subnets, because it's different subnets. But if we've got a single but big range, it doesn't matter, because again, it's the very it's the same entity in the network. Okay, that's why we don't need routing. Sorry, and let me show you the other tool. So ipconfig, okay, ipconfig/all. Look at this nice output here. So if you see, wireless LAN adapter Wi-Fi. Okay, this is my computer's, this is my computer's wireless network card. Okay, this information here, physical address, is my computer's MAC address in the network. It's not my computer, it's my network card's MAC address. Okay, and this is IPv6. This is the scary thing being implemented here recently. So we're all going to forget about IPv4 in the public network. Okay. Yeah, but IPv4 is going to live in private networks. Okay, it's not going to, it's not the end of IPv4. Okay. IPv4 address 192.168.1.132. Okay, this means my computer's IP address in the local network is this one. This is my subnet mask. So this tells me that my local network supports from .1 up to .254. Okay. And my computer for some reason chose this one, 132. And my default gateway, which means my router, is this IP address, 192.168.1, which means is the same subnet as my computer apparently, and it's the first IP address of this range. Okay, and this is my, and if I want to ping, so ping 192.168.1.1, so I'm pinging. Pinging means I'm calling. Okay, I'm trying to discover if my router will reply to me. Okay, and you can see that when I'm calling my router in my local subnet, it replies to me. Okay, I sent 4 packets and I received back 4 packets, which means my router is there. Also, another thing we do, so ping, let's say, let me show you. If I want to check if I can see the internet, so ping 8.8.8.8, it means I've got connectivity to the internet. Okay, because as I told you before, this is the IP address of one of Google's DNS servers. Okay, and another one, last one, if you do ping -t and the same IP address again, this sends continuous pings out to the internet. And if you experience packet loss, so if you see here, my internet connection is very, very happy because I'm getting no packet loss here. But if you ever see some lines saying that it couldn't reply, it means that your line has got some issues. Okay, because if you see any missing packets, okay, every now and then we all have got some packets go missing, but if you see them very, very often here, it means that something's wrong with your connection to the internet. Okay. And that's pretty much it. So let me go back to my original presentation screen. And I don't know, have you got any questions for now? Thanks, Stephen, thanks. Thank you very much all. I hope that you enjoyed this presentation and now you are in a very, very good position in understanding some things in networking. This is my profile in LinkedIn. So if you haven't thought about any questions now, but if something pops in your mind later, or if you want more resources or support in your networking journey, or I don't know, just to network with me, just feel free to find me on LinkedIn, and I will be very, very happy to support you in anything. Thank you very much.